Welcome everybody, it's Ramchandra from CIVIL-MECH MATHS CONCEPTS channel, and I have released 30 lectures on various subjects in civil and mechanical engineerings, and this is 9th lecture on fluid mechanics, useful for both civil and mechanical engineerings for SSC JE, UPSC and state government PSC examinations. As promised, I have brought the first pressure calculations, numericals, so that the concepts are very useful for all the competitive examinations, and numericals are very tricky and also very useful to you in solving the problems in examination. Welcome everybody, it's Ramchandra from CIVIL-MECH MATHS CONCEPTS channel. In the last class, 3 days back, I have promised you that I will be coming up with some numericals in pressure calculations in fluid mechanics. And you please try to understand that there are two concepts which we have to get very thorough, clear concepts as far as velocity of flow of the fluid and pressure accepted on or accepted by the fluid. If you are thorough with these two concepts, velocity and pressure, the fluid mechanics will be very easy to understand and follow. And as far as pressure and velocity are concerned, I have given the sufficient amount of introduction in my last 8 lectures, introductory lectures on the properties, definitions with MCQs also. Typical MCQs I have solved and explained about pressure, types of pressures, and then forces, and then velocities, types of velocities, and how to calculate the velocity. Now, as pressure and velocity are very important in understanding the fluid mechanics basics, let me start with some numericals on pressure, so that till now you understood only the formula, you have understood the concepts, but if you do the numerical problems, then your concepts will be further cleared, and this problem is shown on your screen. This is lecture number 9 in fluid mechanics, numericals 1, pressure calculations. I have written intentionally that it's a complex situation. Situation is complex. Problem is lengthy. But if you clearly understand after doing this problem, the pressure calculations using manometers, calculating the pressures at various levels, under various conditions, you will be able to think that this problem is not as complex as it was written. It's a very simple problem. But the situation is complex. It's again Ramchandra from CIVIL-MECH MATHS CONCEPTS, and this type of problems are very useful for SSC JE, UPSC, Engineering Services Examination, Public Service Commission examinations, and also UPSC Civil Services Examination and GATE RRB JE. From SSC JE point of view, the clearing of the concepts is very important, very vital. If you understand and this problem thoroughly, then your concepts will be very clear. Regarding usage of manometers, calculation of pressures under various situations. Now, as you see on the screen, there is a pressure chamber inside which air is there, and a water pipe is moving or going through. Water is moving or flowing, but water pipe is going through this pressure chamber, and water inside the pressure is at a pressure at point A, that is PA. This point A, center of the pressure pipeline, is at a height of 50 centimeters from the lower level of the manometer, mercury manometer connected to this water pipe. The differential height of mercury column in the mercury manometer because of the pressure exerted by water, because of the flow of the water inside the water pipeline is 300 mm, which is shown in the figure. And water is flowing in the water pipeline. And this pipeline and this manometer, mercury manometer, are kept under pressure inside a closed chamber. They are not put open to the atmosphere. They are put inside a chamber which is containing air under pressure. This chamber is connected. The chamber containing air is connected to an external manometer which is open to the atmospheric pressure. Now, here, there are two types of environments. One is pressure exerted by the atmosphere to the open manometer and pressure exerted by air in a closed chamber to the manometer of mercury, and the mercury manometer is connected to the water pipe in which water is flowing under pressure. Now we have to find out what is the pressure of the water inside the water pipeline. Absolute pressure of the water inside the water pipeline. You please try to understand the absolute pressure in this case for a water pipeline is not gauge pressure plus atmospheric pressure. It is the gauge pressure plus pressure of the air in the closed chamber exerted on the mercury liquid in the U-tube manometer. And the absolute pressure outside the chamber is equal to atmospheric pressure plus atmospheric pressure on the water column plus water column height. The absolute pressure meaning differs inside the chamber and to its connections and open to sky, both are different. The absolute pressure at PA is not equal to absolute pressure at PE, which is open to atmosphere. Please try to understand this. PA is not equal to absolute. PA absolute is not equal to PE absolute, because PE absolute is open to sky to an atmospheric pressure of 101.325. For PA absolute, A is not open to sky, it is open to air. The manometer is open to air. Air is enclosed within the closed chamber. That means air is having some pressure other than the atmospheric pressure outside. We have to find out the absolute pressure at point A. Did you understand the problem? Let me explain again. A water pipeline is there in which water is flowing at a particular pressure. That pressure we may call it as PA. That is gauge pressure. And when water is flowing through a pipeline with pressure PA, it exerts some pressure to the manometer. When the manometer is connected to the pressure pipeline, a mercury manometer is connected to the pipeline and it shows a mercury column of 300 mm, and the mercury manometer along with the water pipeline under pressure is enclosed in another pressure environment, is enclosed in a chamber in which air is putting some more pressure, and that whole combination is connected to a water U-tube manometer which is open to the sky, and the water column in that external manometer which is connected to sky is 60 mm. The mercury column inside the chamber, closed chamber, has a height of 300 mm, and the center of the water pipeline above the lower mercury column height is 50 centimeters, that is height of water. Now we have to calculate pressure inside the water pipeline and also the absolute pressure. This height is 50 centimeters. Now everything is given here. Now let's make certain assumptions. Pressure in the horizontal plane is same. That means pressure at B is same as pressure at B dash. Pressure at D is same as pressure at D dash. And pressure at D dash is equal to pressure at E plus water column height. For that we will go next. And atmospheric pressure at E is equal to 101.325 kPa. The value of atmospheric pressure one should know. Please keep it in your mind. It is 101.325 kPa, 101.325 kPa, 101.325 kPa. The density of water is 1000 kg per cubic meter. Density of water is 1000 kg per cubic meter. We are all doing our calculations in SI units only, because in almost all the examinations of UPSC and SSC, SI units are used and they are mandatory now. SI units. In SI units, the value of atmospheric pressure is 101.325 kPa. Density of water is 1000 kg per cubic meter. Density of mercury is 13,600 kg per cubic meter. Now with this background, now let us try to solve the problem. Now what is the given data? We are going for solution. Please try to understand the concepts. What is the data given? P atmosphere is given is equal to PE, that is equal to 101.325 kPa. Assumption, not assumption, it is PD is equal to PD dash, that is the reality. PB is equal to PB dash, that is as per the laws of physics, and height of mercury column for the inside manometer, height of mercury column is equal to 300 mm, that is equal to 0.300 meter. We have to convert everything into SI units. Then rather PW in terms of HHG, I can say. PW in terms of H water, I can say. How much? 60 mm. .060 meter. That means H mercury is equal to 0.300 meter. H water outside is equal to 0.060 meter. And density of water is equal to 1000 kg per cubic meter, as I told you. 1000 density of mercury is equal to 13,600 kg per cubic meter. These are all the values we know, either given or we know. Then height of water above the lower level of the mercury in the manometer is 50 centimeters. Height of water in chamber is equal to 50 centimeters, that is equal to 0.50 meter. We have to find out PA is equal to absolute is equal to how much? That is our question. Here we have to go into the basics. This is a very good problem, excellent problem to understand the basics and revise your basics. What is the first basic rule of pressure? The first basic rule is, when we move down, moving down means pressure moves positively, pressure increases. When we are moving up, pressure decreases or negative. Pressure on at same level horizontally is same. These are the three basic principles of pressure which you have to understand. The problem may not be this much big and complicated, it will be given in SSC exam, but it can be given in UPSC exam. But however, the basic principle, the basic concept that should be understood is that when you are moving down, the pressure calculations will be positive. When we are moving up, the pressure calculations will be negative. When we are not moving anywhere at same horizontal levels, the pressure is same at all points. What is the reason behind it? I have shown you pressure distribution curve. Let us say there is water here, it is a dam, there is a water, and this is P atmosphere. Then I have shown you in the previous classes, please refer to my previous classes. If this is H, what will be the profile of this pressure profile? As you move down, at the top it will be P atmosphere. As you move down, the pressure increases by H. If H is equal to 1 meter, then P atmosphere plus rho g into 1. If H is equal to 2 meter, it will be P atmosphere plus rho g into 2. This is at the point C. This is at B. This is B, A, B, C. This is D. At the point C, this P atmosphere plus rho GH. If P atmosphere is 0, that situation also I have told you, this will be a vertical triangle pressure distribution. That means from 0, the pressure increases when you move down. For example, if you are swimming in a pond or a swimming pool of some good depth, then when you go down inside while swimming, the pressure on you exerted by the water will go on increasing. When you try to move up, you will be moving towards the atmosphere. The pressure reduces up to atmosphere. That is the most practical example. That means when you move up, pressure decreases. When you move down, pressure increases. That is the basic principle of pressure distribution in statics, fluid mechanics, static calculations of the fluid mechanics. Now, when we are moving down, pressure should be calculated with plus sign. This is the sign convention. Please remember the sign convention. Sign conventions are very, very important in engineering applications. And pressure sign convention is when you are moving down, pressure increases, hence it is positive. When you are moving up, pressure decreases, hence it is negative. When you are stationary and all your points are horizontally in the same plane and with the same elevations, that means pressure is same at all points. These are the three basic principles of pressure. Now, with these, sorry, now you tell me P, D and P dash, are they equal? Previously I have written. Now you understand. Because D and D dash are at the same level horizontally, hence P at D is equal to pressure at D is equal to pressure at D dash. Now, point B, pressure at B is same as pressure at B dash. This is another point. Now, we will start solving the problem with these three basic conventions and sign conventions I have explained you. When you are moving down, put a plus. When you are moving up, put minus to your pressure. Now, the pressures are at various points. We can say PA. We don't know what we have to find out. PB. And another point is PB dash. Another is PC. Open to the air inside the chamber. You please see. PC is open to the air inside the chamber. Then your PD, manometer reading at one end. Not one end, that is manometer reading for the water column, one water column height. And PD dash is open to the atmosphere, water column. And PE is atmospheric pressure open to atmosphere. That is equal to 101.325. As of now, we only know this atmospheric pressure, except that we do not know anything else. Except for water columns and mercury columns. We try to convert water columns and mercury columns into pressure units into pascals and try to solve this problem. Now let us start our journey with at one point. What is that point we will take where we have to find out the pressure? Now let us say PA. That pressure we don't know. Let us move. From PA to B we move. B is at what height of PA? Or what depth of PA? It is 50 centimeters. That means PA plus PB. Before PB comes, there is a water column. That water column, what is that water column? You please see. This is the water column. This is PA. From A to B, this is the water column. HW. Inside the chamber, this water column, 50 centimeters. You are moving down. From A to B, it is moving downwards. A to B. Hence, pressure adds. That means the pressure will be positive. PA plus rho G HW. Correct? Next. PB value we have got. This is equal to PB. Do you agree? This much you agree? PA we do not know. Rho we know 1000 kg per cubic meter. Have we written somewhere? We have not. We have written here. Rho is rho water. G is 9.81. And height of water is 0.50 meter. Everything we are taking in, we will be moving from the point of pressure to be known to the point of pressure where it is known. We are moving from PA to PE. Where PE pressure is known, that is atmospheric pressure. We have to move. And while moving, whenever we are moving down, we are putting the plus. Whenever we are moving up, we are putting the sign as minus. This is one equation. To this, from B, where we have to move, B dash, B and B dash are same. That means PB is equal to PB dash. Now where we have to move? We have to move from B dash to C. That means PC is equal to PB minus rho HG into G HHG. Here from PB dash and PB are same. We found out PB. That means we found out PB dash. From PB dash we are moving upwards. When we are moving upwards, it will be rho GHG minus rho GHG minus rho GH mercury. Rho is mercury. What is the mercury value? PB minus rho is 13,600 into G is 9.81 into Hg is how much? 300 mm. What is 300 mm? That means 0.300 in meters. That means what is PC? PC is this much and PB is PA plus. We'll replace this PB here. Then PC is equal to, what is PB? PB is nothing but PA plus 1000 into 9.81 into 0.50 minus 13,600 into 9.81 into 0.366. This is the value of the air pressure inside the chamber at the point C. Let us say this is equation 1. Can we calculate these two values? PC is equal to PA minus PA plus in SSC JE, in first paper, there may not be calculator, but however, in second paper, if online calculator is given, this type of problems may come. I am not going into the paper 1 and paper 2 like that. We will go on a whole what we can do. Now try to understand the concepts clearly. 1000 into 9.81 into 0.5, that is 4905 minus 13,600 into 9.81 into 0.3, 40025. That is equal to 40025 minus 4905 is equal to PA minus 35120. This is the equation 1. Instead, let us not call this as equation 1. This is the equation 1. A simplified form. PC is equal to PA minus 35,120. This is the value. PC is equal to PA minus 35,120. Let us write it clearly. 35,120. Now, please try to understand another concept here. The air is there inside the pressurized chamber. This air is up to what point? Point D in the manometer, YouTube manometer, kept outside the chamber, exposed to atmosphere. And PD value is same as PC value because the media is same. There is no change in the media. PC is equal to PD. Please try to understand. PC is equal to PD. Why? Because there is no obstruction for air to move to D. There are no walls. There are no obstructions. That is directly connected. Some point when it is directly connected to another point and it is in equilibrium, then both the points will have the same pressure. PC is equal to PD. Please try to understand that. PC is equal to PD. Another important concept you have to understand. When you have two balloons in your hand and one balloon is connected to another balloon by a small pipe, when the air pressure in one balloon is equal to the another balloon, that means the sizes of the balloon, the pressures in these balloons will be same and there will not be any pressure difference. If you pump one pressure inside one balloon and keep another balloon as it is, then the pressure from the other balloon comes into the second balloon and the second balloon also expands till the pressure in both the balloons becomes equal. As the system is static and system is under equilibrium, the pressure at C is equal to pressure at D. Because the medium is same, that is air, and there are no obstructions in the connection, pressure at D is equal to pressure at C. Please try to understand this concept also. This problem I have taken to clear the concepts for SSC JE and also other GATE and UPSC aspirants. GATE and UPSC aspirants can try the numericals like this, but SSC JE aspirants can understand the concepts. The pressure at C is equal to pressure at D. You see, C and D are not at the same elevation, but they are connected to each other by the same medium, and the system is in equilibrium. Pressure at C is equal to pressure at D. Now, what is the pressure at D? Pressure at D is equal to pressure at D dash. Do you agree? Which implies, what is pressure at D dash? We'll know now. Now, till now, what is the journey we made? Let us make a small journey map. We started from here. We moved up to here. Then again we have moved up to here. Now we have moved up to point D. Now we will go down and move up to D dash. We moved up to D dash. Now we will move up to E. Now, don't jump conclusions. Don't jump to conclusions. Complete the process. We have to move from PA to PE. PE is known. Pressure known. PA, pressure is unknown, to be found out. When we move from unknown to the known, then we can know the pressure at A. To find out. Here it is known, already known. We know the pressure. Now, we moved up to D. Now up to D dash also we moved. PD is equal to pressure at D dash. Now from D dash to E. D dash to E, is it moving upwards? Moving upwards. Means negative sign. That means PD dash minus, what is that? Rho GHW outside is equal to PE. Do you agree? P at E is equal to PD dash minus, because we are moving up. Because we are moving up, PE, it is PE, it is PD dash. PD dash minus, this is HW outside, HW outside into rho G. You understood? Which implies PD dash minus 1000 into 9.81 into, what is the height of water outside? It is 60 mm. 60 mm is 0.060 meter. That is equal to PE. What is the value of PE? PE is open to atmosphere. PE value is equal to P atmosphere. Here we have written PE is equal to P atmosphere, 101.325 kPa. What is PD dash? PD dash is equal to PD. What is PD? PD is equal to PC. That means this is the equation number 1. PC is equal to, from equation number 1, PC is equal to PA minus 35,120. Everything in SI units, Pascal. We are not changing the units anywhere. whereas PC is equal to PD is equal to PD dash. By replacing this in the PD dash formula, this is formula number 2. Replacing this value in formula number 2, what happens? PD dash is PC minus 1000 into 9.81 into 0.060 is equal to 101.325 kPa. When you convert into PA, it will be 101.325 Pascal. So let us change everything to Pascals, because all other values are in Pascal. Now what happens? PC is nothing but, this PC is nothing but PA minus 35,120 minus 1000 into 9.81 into 0.060 is equal to 101.325 Pascals. This is the solution. That means PA is equal to 35,120 plus 101.325 plus what is this value? 1000 into 9.81 into 0.060. That is equal to 9816. This total value is 35,120 plus 101.325 plus 9816. 146,261. This is the Pascal. Then the question comes, what is the value of absolute pressure at PA? What is the absolute pressure at PA? The absolute pressure at PA is same as the pressure at PA. The reason being, point A is not exposed to the air. It is again closed by the pipeline. That means PA absolute is equal to 146,261, that is 146 minus 0.261 kPa. This is the pressure inside the pipe. This is the pressure inside pipe. Now you please try to understand the concepts. Because whatever pressures we have taken here, PC and PD, they are absolute values. Hence, PA absolute is equal to 146.261 kPa. Now, you please try to understand the concept here. Whenever we move down, the pressure increases, and when you start your journey, at the point where you have to find out the pressure, please don't leave the path. Go and move till you reach the point where you know the pressure. till you reach the point where you know the pressure. Here you see you started your journey at A, went to B, then you went to C, then you went to D, then you went to E, where PE is known. When you are moving down, it is positive. From A to B, you have added the pressure column. When we are moving from B2 or B dash to C, the fluid column pressure is subtracted because we are moving upside. Then we move to D and D dash to E. Again, the column pressure, the fluid column pressure is subtracted. The net value is 146.261 kPa. The answer is not much important. The important one is you should understand the absolute value means you should not add the atmospheric pressure. When you are under another pressure chambers, then that pressure has to be added. For the absolute pressures, when something is closed, then absolute pressures will not be on the fluid, rather they will be on the surface of the fluid. That means they are on the metal surface, not on the fluid, directly fluid surface. Hence, the absolute values are the pressure with which water is flowing in the pipeline are same inside the pipeline because its fluid is moving. Hence, we can say that PI is equal to this particular value, and try to understand that I have used two different liquids here. One is water column manometer and another is mercury column manometer. We can sometimes, to make more complicated, within the manometer itself, two fluids can be used. Let there be any number of fluids. Let there be any number of manometers. When you move upside towards downward, then you add the pressure of the fluid column. When you move upwards, you subtract the value of the pressure column and start from the where pressure has to be found out, go to the point without leaving the path till you reach the final point where pressure is known. Today I will stop this lecture now. Maybe tomorrow or day after I will come out with another typical example like this for pressure measurement, so that at UPSC level, so that SSC JE people will be benefited by these concepts getting cleared, and UPSC people or GATE aspirants, they may get the practice problems with them. Best of luck to everybody. It is my 30th video in the channel CIVIL-MECH MATHS CONCEPTS, CIVIL-MECH MATHS CONCEPTS, and it is my ninth video on fluid mechanics, and I am coming up with one textbook in Amazon for fluid mechanics MCQs. My MCQs will be totally different. and they will be fully concept oriented. Maybe in a couple of months I will be uploading my book in KDP, Amazon, and you can view it from Amazon. If you want to purchase from Amazon, or if you have Kindle Unlimited subscription for some time whenever Amazon offers, you can read it free of cost. Or if you want physical copies also, you can order from Amazon. I will be giving the details once my book is ready. The standard of questions and concepts will be of this type. First I will be starting with fluid mechanics. Then from fluid mechanics I will move on to hydraulics. From hydraulics I will move on to water engineering. Best of luck to everybody. It's Ramchandra again from CIVIL-MECH MATHS CONCEPTS. Try to view my other 30 videos also. If you feel my videos are good, please subscribe to my videos, share it with your friends, and try to comment on the videos so that I will improve in the next coming videos. Best of luck to everybody. It's Ramachandra from CIVIL-MECH MATHS CONCEPTS. I am an IITian. Best of luck to everybody. Thank you.